So just to editorialize a little bit before I get started, I want to let you know that this is more of a message than a substance talk. This is more of a medley talk than diving deep into one particular topic. I know some people like one style, some people like the other style. It's like when you go to your friend's house and they say, I'm a real big Beatles fan, and you look at their record collection and all they have is Billboard Top Hits 1963. You say, you're not a fan of the Beatles, you're just a fan of popular music. This is one of those talks. That analogy probably made no sense to any of you. Don't worry. The rest of the talk, it doesn't get any better from this. So let's get started. This is Don't Live Patch Your CPython Interpreter. I'm James Powell. We're at PyData Chicago. It's Saturday, August 27th, 2016. So one thing that you might have seen on the title slide is my Twitter handle is Don't Use This Code. So if you want, you can follow me on Twitter at Don't Use This Code. That's also my email address, james@don'tusethiscode.com. And you might wonder, why do you choose that Twitter handle? And there's a very specific reason for that. I like to play with code. I like to play with ideas. And if you've ever been into the Python channel on IRC, there's a lot of really mean people there, a lot of jerks, who every time you give some advice to somebody, they'll shout you down. So if some newbie comes in and says, can you do such and such in Python? And you say, well, you can, but you shouldn't. They'll say, no, don't even tell them that. Just tell them this pre-described list of explicit things you should do. They're the kind of people who ask, whenever you have a question, why do you want to do that? Because they don't want to just answer the question directly and legitimately. So I thought, if I call myself Don't Use This Code, then I can sidestep some of these. I can show people some neat stuff, but there's always this built-in disclaimer that you shouldn't really do this. This is for fun or for education or for exploration. I want to show you a couple of examples of some of these things. So some Don't Use This Code examples for exploration, and these are all gists. Hopefully these pull up really quickly. Uh-oh. Oh, there we go. So one thing, this is just something I did for exploration. Somebody asked, oh, can I do auto-initialization of instance variables, of member variables in Python? I said, well, you could, you probably shouldn't. It's not a Pythonic way, but if you wanted to, you could use annotations to do this. So you can see this class uses annotations, and it says that x's default value is x plus y, y's default value is y times 10, and you have a really small little meta class that's 5 lines long that allows you to do this. Sometimes these things are just to be cute. So, you know, there's this weird relationship between things like mappings and dictionaries and things like functions, and I thought, well, isn't memoization just kind of looking something up from a dictionary? So this is my ideal memoizing decorator. It's basically a subclass of the dict operator that implements missing. And I thought this is a really cool combination of a bunch of small little topics that you might run into when you start thinking very deeply about what it means to memoize a function. And there's one really neat feature of this, which is it memoizes independent of the signature. So independent of whether you pass something as args or quargs, it uses the signature module, or rather the signature function in the expect module, in order to abstract over the different possible ways that the function could be called. Sometimes these might even be useful. So somebody said, I have a big production system and I needed to rename some of my modules. What should I do? What's the best practice? So I said, you know, there's this feature in Python called import hooks. And with about 30, 40 lines of code, you could write an import hook so that when somebody tries to import a module called, in this example, moth, it actually imports the module called math. So you could take a large system and you could say, this module is renamed to this, and you could even, with so little code, you could even set up things like warning dates and exception dates. So if you try and import a module under its old name, after a certain date you get a warning, after a certain date you get an exception. And I said, you know, this could actually be useful, and it's a fairly well understood example. Import hooks are a pretty robust mechanism. There's not a lot of risk in using them. So this is something that you could actually do in production to accomplish a real task using some advanced feature of Python. Sometimes these things are completely and utterly bizarre. So a friend of mine had a problem, and it's too complex to really say what it was, but basically the solution that I gave him was, can you write a meta class that swaps the order of derivation? So you have a base class and a derived class. Can you create a meta class so the derived class is actually the base class and the base class is actually the derived class? So in this example, here you have a meta class where here's some library code that you write, and the user subclasses that library code, and the user thinks that they're the one who's the ultimate derived class, but in fact the meta class swaps the order of derivation, so the library has the ability to enforce constraints on user-derived code. And there was an actual real reason that he wanted to do this, but this is so utterly bizarre that I don't even know if this would really work. I know in this particular example it does, but I can see half of you have no idea why you'd even want to do this. I can't even remember exactly the reason, but I think it was related to wrappings of PDB. So we're getting a little bit weird. Sometimes I come up with these things in order to prove somebody wrong, which is never a good reason to do something. A long time ago, somebody made an assertion in a talk that just rubbed me the wrong way about whether you could compile Python, and it put me on an 18-month quest to show different ways that you could embed Python into each other. This is Py3 SO2. There's no C code here. There's only CFFI calls. This is a 100-line Python script that starts a Python 3 interpreter, starts a Python 2 interpreter within the Python 3 interpreter, and starts a Python 1 interpreter within the Python 2 interpreter within the Python 3 interpreter, so that they're all in the same memory space but completely separate from each other. So all three of them can import C libraries, but they don't share any of that global state. They're all running in parallel. There's no process boundary between them. Why you might want to do this, I have no idea, but it did prove that person wrong. So mission accomplished there. Sometimes these things are just about pushing the boundaries. So, everybody likes to talk about explicit self, and some people complain about explicit self. So I thought, let's push the boundaries of good taste and see if we could do implicit self. So here's a little example of these two classes that no longer take an explicit self variable. They have an underscore self variable that's implicitly created. What I did was I live patch a CPython interpreter using C types to make the closure mutable, and then I inject into the closure the self variable, and I do a little bit of bytecode patching. So this is kind of beginning to push the boundaries of what's possible in terms of mucking around with the CPython interpreter, and also pushing the boundaries of good taste. I gave a talk earlier this year kind of about Dadaism at PyData Amsterdam, and you can see one of the tenets of Dadaism is really testing the boundaries of what is socially acceptable. And sometimes these things are just utterly and completely atrocious. So I wanted to show you an example of one of the worst things I've ever done. This thing was so bad that it actually made me bored with hacking the CPython interpreter because I thought I can never top this. So I want to spend 1 or 2 minutes to just show you this example. This is all just a prelude to my main point. So I created a pip installable module called rwatch. Some of you who are users of GDB know you can add read watches in GDB. I thought, could you add read watches in Python? Could you create a mechanism in Python so that every time somebody looks at a variable, not uses it, but just looks at it, it calls a hook? And it turns out you can. And I want to show you what you can do with it, and then I'll show you how it works, and then we'll talk about why you should never do it, and some qualifications on that. So what you have is a module that you can pip install. Now I usually don't pip install it during these talks, just because if the internet's wrong, it could throw everything off the rails. But trust me, if you have a Python 3.5.0 and only a Python 3.5.0 interpreter, you can pip install this mechanism, and you'll be shocked at what it can do. In your code, you import rwatch, and then what it does is it adds two things to the sys module: set rwatch and get rwatch. Set rwatch sets read watches, get rwatch shows you what read watches you have. What is a read watch? It's just a function like this. This function says, I saw some object at some frame. Here, I create an object, just the number 10, assigned to the name x, and every time I look at that variable, it triggers that callback. So I'm going to cut and paste this code into an interpreter, and I'm going to show you it working. So here, I have the x variable. It called my callback. I say x plus 2, it called my callback. I put x into a function. It called my callback twice, once on the way in and once in the function itself. So every time that variable is looked at, not dotted access to it, not anything, every time somebody looks at that, it calls my callback. And the interesting thing is, what could you do with this? Obviously, there's some debugging purposes. That's the initial motivation. Can you create a callback so that every time somebody looks at a variable, you know? And I thought for very big data pipelines, sometimes you have 1 million data items, and one of them is just throwing a wrench into things. So maybe you could just see, when is this data item looked at? Where in the pipeline is it getting mutated in some undesirable fashion? It turns out you can do some really interesting things, because in the callback, if you just raise the runtime error, then you have basic sandboxing. So in my Python interpreter here, if I paste this code, here, I can never access this x variable, because every time the callback is called, it raises a runtime error. So I have very basic sandboxing. Pretty neat. Turns out you can do even worse things. Here, you can think that if I have the ability to do something every time a variable is called, and I can return my own thing, I can do very basic promise lazy mechanisms. So here, every time the object is looked at, it calls a method. In this case, the method just sleeps for 1 second. So I'll show you that example. Usually I have enough time to type these out, so I apologize for going a little bit quickly. Every time I look at x, behind the scenes, it calls a function, and it returns some particular value for that. So notice, it takes 1 second to look at x, because behind the scenes it's doing some long-running function. In this case, it's just asleep. So you could think a lot of future mechanisms, a lot of promise mechanisms, are some ugly syntax on top of, I do some action, I let it sit there, but when I need to look at it, I then invoke the time that is required in order to actually perform that action. You could also implement pointers in Python. So you could think, what is a pointer but a mechanism for indirection? And what is this but a mechanism for indirection? So in this example, let's restart this. Here, I have a variable x, and it's number 1, 2, 3, 4. I have a function x underscore that repoints x at another variable. So I now point it at z. Now x is 4, 5, 6, 7. This is a value type, and I can point it around. So now I can add simple pointers in Python without these weird cell mechanisms that people end up having to use using lists with one element or whatnot. And the final thing that I can do is I can ruin your day. So I'll show you my favorite example, and I'll take a little bit of time to go through this. In my callback, instead of returning the object, I return the object times 2, if that object is an integer. So now 1 is 2, 2 is 4, 1 plus 1 is 4, 2 times 2 is 8. I could really ruin your day. How about that? So you can see with a mechanism like this is absolutely and completely atrocious. Why on earth would you want to do it? Well, there's some reasons for debugging purposes where you might want to do something like this. But before I get into why or if you'd want to do this, let me tell you how I did it. Because when you see how I did it, it'll shock you a little bit further. This is just, this is the source code for it. It's a pip installable module, so this is the directory where the source code is. And you can see there's a C component. It's a C module. And of course it's a C module because it's patching some parts of the Python interpreter, namely it's adding things to the sys module. So if we look at rwatch.c, we can see here's the get rwatch, and there's the set rwatch a little bit above. And there's nothing that interesting in here. It's just setting some particular state on the thread, and it just injects these things into the sys module. That's not it's a fairly unusual thing for a Python module to do, but it's not impossible for a Python module to patch existing C modules. It does something very interesting in the initializer, which is it calls this thing called hook function. And it calls hook function on PyEval frame x. Hook function is a little toy that I wrote a while back, which finds a publicly addressable C function and assembly smashes it, so it jumps to another function that you have. PyEval frame x in the CPython interpreter is the main interpreter loop. So what I'm doing is, in my pip installable importable module, live at runtime with no need to modify binary on disk, I find the main Python evaluation loop, I put a little assembly trampoline, and I trampoline to my own version of it. And in my own version of it, I can do pretty much whatever. And that's how I implemented rwatch. And so one thing that you can see in this is there's 2 subdirectories in this for Python 3.4.3 and Python 3.5.0. I'm assembly patching the main interpreter loop for Python, so it's very specific to the Python version. rwatch only works on those 2 versions. It could very easily be patched to work on any 3.5 subversion, but I'm just too lazy to do that, and nobody really wants to use this in production anyway. But the reason for that is very tiny, otherwise inconsequential, non-API breaking changes to CPython source code break rwatch because it's such a weird mechanism, swapping out the interpreter loop. I want to show you what the interpreter loop does to swap it out, just to drive this further. So here is ceval.c. This is the main interpreter loop for Python. So if we search in this file for a for loop, somewhere in here we'll see this. This is the actual main interpreter loop for Python, and you can see if you scroll down, these are all the Python bytecodes. Load const for loading a constant, binary multiplies below, rot2 for when you have xy equals yx, rotation of the variables on the stack. All I did, and this is a diff view, is every time a variable is pushed or popped to the top of the Python stack, I just call my callback. And that's it. So you can think that every time some variable hits the Python internal VM stack, you have the ability to call a callback, and suddenly you have the ability to add all these amazing indirection mechanisms to really fundamentally change the way that the language of the interpreter works. And you can pip install it, because you don't have to patch the interpreter. This works on Mac and Windows. There's nothing more than a C compiler that's needed to actually install the module. If I created a wheel, you wouldn't even need a C compiler at all. You could just have the .so on disk and it would just work. Now, that's meant to shock and appall you. And I actually presented this earlier this year at SciPy. I presented this plus a couple of other things that I did with the CPython interpreter. I added abstract syntax tree literals. I added a type of eager evaluation to Python. And the point of that talk was to show what is possible to do and then to discuss why you might or might not want to fork the CPython interpreter. For this talk, I wanted to take this somewhere different. Because one question that I get often is, what do you do for work? You know me from the keynote. I came on to talk about NumFocus, but I don't work for NumFocus. I'm a consultant. I write code for money for people who need code written. And how many of you, having seen even one of these atrocious things, ever want me anywhere near any of your production code? Not a single hand is raised. So clearly, I want to show this to you to show you what's possible, but I want to tell you that there's no way I'd ever do this in production because, I'm a consultant. I want your money. I want you to pay me money to write code, and I want to tell you that I'd never write this kind of code for production because it would terrify, it'd scare the living daylights out of the next engineer who comes along to look at it. And so in that talk, I said, you shouldn't do this. You should never do this. And there was a little joke in that talk where at the beginning I explained the don't use this code thing, and at the very end I said, so should you ever do this? And the answer is no, don't use this code. But I wanted to get into the reasons behind this and some of the judgment and some of the thinking behind this and go a little bit deeper than what I did in that talk. Because it's not just that I want to have friends. It's not just that I want you to use my code in production. It's not just that I want to get business and to convince you that these techniques are possible and these techniques give you some ability to think about problems a little bit deeper, but you never actually do any one of these with maybe the exception of like the memoize thing in any production code. And even then, you might have to really sit down and think, is this something that I care about? Or do I care more about solving some business use case than writing some crazy code that's completely self-indulgent? However, something very interesting happened a few days ago. Our keynote speaker for tomorrow, David Beasley, or one of our keynote speakers for tomorrow, David Beasley, tweeted this. He said, instead of installing packages, I think I'm going to start a new movement of simply modding the Python interpreter itself. And immediately, Tom Caswell, one of the matplotlib developers, said, don't use this code, it's already working on this. And then Aaron Muir, one of the CPy developers, responded, hey, look at this talk. And it started a somewhat short Twitter discussion about why you'd ever want to do this. And I said, no, please, Dave Beasley, don't do this. It's a bad idea. And I didn't get permission to name this talk, Dave Beasley is wrong, don't live patch a CPython interpreter. So I had to cut that part out. But I wanted to show you some judgment or some reasoning behind why this is something you'd never really want to do. Because I could tell you some legit problems and some legit nitpicks with this approach. I could tell you that it's completely bizarre. If you look at this and you have no idea what to make of it, this is something that nobody else is doing just because it's such a ridiculous thing to do. I could tell you very practically, there's no Windows support for this mechanism. I can live patch a CPython interpreter on Linux, on OS X. Oh, and by the way, don't think that memory protection on Linux means anything. If you have a proc file system, you can write through the proc file system. If the page is marked as read-only, doesn't matter. You write through the proc file system. It's always read-write. I don't know if it's the same case on OS X, but I wouldn't be surprised if it is. Unfortunately, Windows is a completely different beast. This doesn't work on Windows. Windows actually has its own mechanism, as I understand, called detours, that allows you to do this kind of live patching in a safe way. And apparently that's used for things like hot patching the Windows kernel when you have updates on machines that can't be rebooted. I could tell you that there's a legit problem that I have to have these per version, and not per major version. I have to have per minor version patches of the CPython interpreter to actually make this work, and that's a lot of maintenance burden. I have to have one version of this for every 3.5 dotted release from there. It's not an enormous amount of work. The change is only 50 to 60 lines long, but I'd still have to maintain it in a lot of different places, and it's very rare for somebody to say, oh, this module works, but only in Python 3.5.0 from last Tuesday. Anything else and it breaks. That's a very rare thing to happen. I could tell you that, there's no PyPy support for this mechanism, and it's very much a CPython mechanism. It only works in cases where you have literally CPython, not just Python that uses a stack-based virtual machine, just CPython only. But of course, you could just tell me that nobody uses PyPy, and we'd move on to the next slide. It doesn't work with C code. There's some weird corner cases for this. Certain literal syntax just kind of falls through. Clearly, I can't capture things which look at variables in the C layer. So inside methods for objects that are implemented in C and Python, like the dictionary object, I can't see if something's being done in that dictionary, like if a key is being set or if a value is being retrieved, until it reaches the level of the CPython main interpreter loop, the bytecode area. So I can only capture read watches on things which include bytecodes. So there's a lot of area within many very commonly used C modules, like for example NumPy, where the read watch just doesn't work. And one problem with this is it makes it a very obtuse thing to explain to people. Because I could tell you I can add read watches to Python in these very limited circumstances if you understand how CPython as an interpreter works. That's not a case that I'm going to make. And you might say, well, this is great. I might use it for a million things. And then suddenly one of these little corner cases pops up. Oh, my code is passing through NumPy, or it's passing through some module that somebody wrote in Python. And suddenly the read watch fails to work, and it's completely inexplicable why it fails to work. And some mechanism that you've built on top of that's important fails to work. So it makes it very obscure. And I can tell you there's some unpredictable behavior associated with that, because when we start to take into account cases where you could pass through Python generated via Python, or rather C code generated via Python, then we could have some weird unpredictable behavior if you built a mechanism like the promises or something less on top of it. But I want to give you a better reason why you shouldn't do this. And I want to say it's a matter of judgment. And to really press upon you why it's a matter of judgment comes down to something that I saw a couple of days ago when I was just reading various blogs. Somebody said, yeah, we're not really impressed with Docker support. We've seen a lot of point releases of Docker that were unstable, so my company runs a custom Docker. Some of us are terrified to run our own custom image, much less a custom Docker. And I thought this company has full confidence in the ability to run custom self-patched code that's part of their infrastructure. And I imagine most of you in the audience, if I told you there's 1 or 2 bugs in NumPy, go patch them yourself and use that in production, it's completely out of the realm of what is feasible for the tolerance for that level of technical sophistication. However, that's not true for everyone. So I want to give you a couple of examples of that. I love make and I love makefiles, and I use make and makefiles in many places where they're not well suited. And sometimes I'm working on a project and I need to either share that project with the organization that's paying for that project, or I'm bringing other people onto that project to collaborate with me. And I have to have that very uncomfortable discussion, which is, here's the crazy way that I do things. Can you please follow all of these indulgences and all these crazy things? And one of them is, I really like make. And a lot of you will say, make is a horrible tool, never use make, don't even use shell scripting. But I feel that make has never really, I know there's specific limitations, there's cases where I wouldn't use it, but I feel comfortable in the places where I do use it. Or metaclasses. A long time ago I saw a talk called Don't Use Metaclasses, and I thought this is a garbage talk. Because clearly metaclasses give you a very specific mechanism that up until very recently, there's no other way to specifically do that. Namely, metaclasses in a soundbite are one of the only ways you could originally enforce a constraint from a base class to a derived class. There are many ways to enforce constraints from derived classes to base classes, but the other way around, metaclass is really the only mechanism to do that. So to tell somebody, don't write metaclasses, is to tell them, here's something that you need to be able to do sometimes, don't do that. Just find some other more convoluted way to do it. In some cases, metaclasses are a very short and very concise way to do something, and they can be pretty predictable. That said, for the swap meta example, where I swap the order of derivation, I have no idea if that actually works outside of the limited example. That's something where we're touching the boundaries of human knowledge. I don't think I understand how the type mechanism in CPython works well enough to tell you that this is actually safe to do in even your own demo code. Similarly, oh, by the way, PS, Python 3.6 adds init subclass, which is a safe way to use metaclasses. And there's a lot of complaints about metaclasses. I would use a metaclass in any case where it's library code that somebody's not going to derive from, and there's no multiple inheritance burden, because sometimes metaclasses and multiple inheritance give you all sorts of crazy They break the model in some ways. In its subclasses, Python 3.6's approach to solve that. But I can tell you, in short, there are some legitimate cases. There's some legitimate places where you might use a meta class and some illegitimate places. One thing that you might have peeked at when I was running my Python interpreter was I run my Python interpreter using this tool called BEMV, which is short for Better Virtual Env. I don't like Virtual Env. That's how I start projects when somebody's going to join. I say, I don't use Virtual Env because I don't like it, and I gauge from the look in their eye whether they think I'm crazy or not. And it sounds absurd. You don't like Virtual Env, so you wrote your own? That's absolutely ludicrous. But if you look at BEMV, it's just a shell script that's about 50 lines long, and it's very well understandable. And if you don't like using BEMV, you can still go back and use Virtual Env. But I don't like Virtual Env. So there's a place where that judgment, some people agree and some people don't. Or custom kernels. I run a custom kernel on my laptop, and when I say that, you're all getting a thought in your mind, oh, he's one of those guys. But the reason for that is I happened to buy a laptop that didn't have very good hardware support for one of the pieces of hardware that I was configured with. I run a distribution where installing custom kernel was literally a single command line, pack-AUR-S, and the name of the kernel. There's no updating, it's just as easy as apt-get. I run a custom kernel. But some of you would think custom kernels, oh my goodness, it's the extremes of what somebody might want to do. Somebody came to me with a desire to pay a lot of money for a forked CPython that they wanted to use internally at their organization. They didn't want to use the CPython that's available at python.org. They wanted to fork it and use it themselves. What? And except, if you look at a lot of big companies, Google has their own internal forked CPython. If you go to PyCon and you go to their booth and you listen to their talks, they talk about it all the time. YouTube has their own forked CPython where they added a bunch of stuff to it. A lot of these really big companies which have the ability to support something as ridiculous as a forked CPython have them. I wouldn't be surprised if the company that came to me willing to pay me this money is the last of the companies of that size to actually get on the bandwagon of forking CPython. So for something that you consider to be the most outrageous of all of my examples is par for course for companies of a certain size with a certain tolerance for technical sophistication. So when I thought about this, I came back to something that a quote that I had in an earlier presentation that I gave a couple of years back. And the question was, what's the difference between good code and bad code? I'm sure all of you know the answer. Good code is code I wrote. Bad code is code you wrote. It's the same thing with technical judgment. Good judgment is my judgment. Bad judgment is your judgment. So there are a bunch of you sitting in the audience right now, and I've given you all of my, equivocating all of my qualifications for why sometimes these things are useful, and you're like, this guy is nuts. His judgment's horrible. And then, probably in about a week or two's time, you're going to do something where other people in the room would disagree with you, and you'd say, but, what about the extenuating circumstances? That's how it works. So what I thought in this talk that I would do to try and answer this question as truthfully as possible is to discuss with you some ways that this judgment can be guided. Because it's clear that there are some very weird and wild things you can do if you submit yourself to the gods of technical sophistication. If you're willing to do whatever's crazy, whatever's theoretically possible, and you have no qualms and no... I don't want to go further than saying you have no qualms, but if you have no inhibition to submit yourself to just whatever you can do. If you never think, well, I can do it, but should I? That never comes up. This judgment can be guided. It can't be systematized. I can't tell you strictly why a forked kernel is good in some cases or why a forked Python makes sense for this company but not that company. But I can give you a couple of questions that I ask myself when somebody comes to me and says, I'm going to pay you money to do something, and if it breaks, your butt's on the line. And I say, well, I want to do the simplest thing possible because I don't want it to break. And because I live in New York City, so I kind of want to live a nice life, right? One of the questions I ask myself is this a model or a mechanism? In many of the cases here, what I've done, like meta classes are usually a mechanism. They don't add a model. They don't add the overhead of this is a new abstraction you have to learn. It's just a mechanism to accomplish a task. And in many cases, when you look at things, you can say, there's a way to accomplish this task with a mechanism that uses subclassing or uses M4 or uses macros or something like this, and it's 100 lines long, and there's a mechanism that's 10 lines long. And you might say, well, all I'm doing is implementing this mechanism. I might as well use the shorter version if that matters to me. So sometimes there's a big distinction in terms of the application of technical judgment as to whether you're creating a new model, a new abstraction, you're fundamentally changing the way you think about the problem, or you're just implementing some mechanism that's used in the process of solving the problem. And you can think about that for a lot of these things. BEMV versus virtual env, this is the mechanism. The mechanism is isolation of Python interpreters. So it doesn't really matter how you accomplish that, as long as you're not adding overheads that your deployment team can't manage. Not really. If you're fundamentally changing the way that Python modules work, then that's something different. Do you understand it fully? Swap meta, I promise you, swap meta was a young kid named Joe Jevnik who has examples that are even weirder and even wilder than mine. Look them up on GitHub. Quasi-quotes is one of them, where he embeds R code into Python code. He embeds C code into Python code, and they can interact with each other. This kid is absolutely nuts. And I thought, you're a young kid, but I still have some youth in me. So here's a problem that we're going to try and solve. We're going to race to solve it. So we raced, and it took me 24 minutes to get the answer. It took him 26 minutes to get the answer, and I thought, not bad for an old guy. But I don't understand it fully. I don't really understand what that mechanism does. It kind of works for the limited case of just proving somebody that something could be done, but I don't really understand it fully. And in many of these cases, you might say, well, do I really want to take the risk that I've misunderstood what I've done? In the case of things like import hooks, I can tell you anybody who spends a couple of hours with the documentation on import hooks can understand how import hooks fully dead stop. So a lot of things that you can do that are pretty neat with Python and with large deployment environments, large production systems that you can accomplish with import hooks, I would encourage you to do, because there's really not a big barrier to understanding it fully and being able to say at the end, this rename hook thing, it actually works and it probably won't ever break in ways that are, it'll break in predictable ways. It won't break in some way that'll just totally blindside us. One way to gauge that is how precisely and how concisely can you explain this. So for example, read watches, if I could make that work fully, I could explain it very precisely and concisely. It's a callback anytime something's looked at. But one of the main problems with it is I can't explain it precisely or concisely because it's not really that. It's a callback where for whenever a variable is looked at, subject to the following qualifications, that it's only if you're using CPython and only if it's a variable that's popped to the top of the Python stack or that's pushed to the Python stack, so forth and so on. This is where the problem lies. It's not, there's a leakiness to this abstraction. One other question that I ask myself is how superficial is this change? So the use of something like BEMV or virtual env is very superficial. You can swap it out very easily. Some of these small changes are very superficial. But one of the things that I showed at SciPy was the addition of new syntax to CPython. You could represent abstract syntax-lit trees. And the reason for that is you could do some nice APIs like you get in R, in Python, but it was not a superficial change. It's a change that fundamentally changes the way that you would write your code in the Python language. So to ask somebody to give them that burden of learning my own particular version of Python, it's not very superficial. The person who's paying me to do a forked CPython, the changes they want to their forked CPython are actually remarkably superficial. So they're not changing the language to add static typing. They're not changing the language to make it more like C++ to add curly braces everywhere. They're doing it for some very small, very superficial use cases to accomplish very targeted goals. But the language, for the most part, will remain completely unchanged. And so somebody who learns Python independently from Coursera, from edX, is going to come to that organization and use their forked CPython, and they're not going to notice anything that's that different. For the YouTube CPython, you get into kind of the gray area where maybe your forking of CPython adds things to the language which people have to learn about. And you never want that to be the case when you join an organization. They say, we use so-and-so popular open source project, but not really. We have our own version of it. You never want that that's a huge warning sign. You never want that to happen. One really important qualification is how perfectly do these mechanisms work. So some of these mechanisms that I showed you at the beginning work more or less perfectly. They are complete, but the question is really how perfectly does it have to work? Read watches are something that I actually do use and I actually would use, because in some circumstances it doesn't actually have to work perfectly. I use them for debugging. So my production code runs a stock CPython, no changes to it whatsoever. But when I'm debugging something and I want to figure out where a bug is, I use read watches. And if it breaks, who cares? I'm just debugging. If it works and it helps me find a bug, I fix the bug in the code, but the patch CPython interpreter is not what I'm using in production. So there's very low bar in terms of how well this mechanism has to work because it's used in a very limited circumstance. I have considered using read watches for things like documentation generation, where at PyData Berlin this year, I gave a talk called Quarg, where I said, you have these APIs in pandas and matplotlib, and you look at the help text for that, you look at the doc string for it, and it has star args and star quargs, and you can't tell what variable names it takes. You could use read watches in order to figure out what variable names it takes by running through the gallery of all the sample code and seeing at which function the various arguments you pass in are actually looked at. And you could build a graph of, matplotlib calls this helper, calls this helper, calls this helper, calls this helper, and these are the variables that are used at each level, and you could supplement the documentation. And the end product would be better documentation. And so if the mechanism didn't work perfectly, the documentation might be slightly missing something. You might be able to say, this takes star args and star quargs, and we know that the star quargs includes these things, but may include other things. That's not a very big burden. It's not a very big barrier. One other important question is, what's the scope of the effect? How big is it? What kind of burden are you putting on the next person in order to accommodate your technical sophistication? Because I will tell you, here and now, we are all guilty of indulging ourselves with technical sophistication, of wanting to do something that's cool and writing code that's more cool and more fun than it is actually useful. And sometimes we snap to our senses after 2 or 3 all-nighters, making something work, and we say, great, I made it work. But we just give it to the intern and just have them spend a summer, doing it by hand, doing it the dumb old manual way. Or, oh, I got my little module to work, but let's just pip install the one that's crappier because that's what people know, right? What's the scope? What's the burden you're putting on the people around you? How big of the change is it? How much does somebody have to learn or understand before they can actually enter your now distorted world? And then I think the last question is, what if you're wrong? What if you've employed some technical sophistication and you thought you did it right, but you didn't? What if you missed something? What does that mean? Can you risk that? And the answer is, in most cases, you can't. So when I'm writing code for people and they're paying me money, I can't risk it if it's wrong. It's my reputation, it's my business that's on the line. I can't give you something that's totally crazy that solves your problem very easily, but then breaks and takes your business down. I wouldn't stay in business. So oftentimes I stop myself, I aver, I don't do these things because I say, even if there's a 1% chance of me being wrong, that's too great a risk. One of the biggest markers for why people employ technical sophistication is their appetite, their budget, their risk tolerance for technical sophistication. And so oftentimes when you look at the actual code that I write for actual money, it's very simple, very basic code. I use standard libraries. I don't really I don't do things super tersely. I do things in a Pythonic or idiomatic fashion, but I do them in a way where if somebody comes to me and says, we paid you all this money and that's what you wrote, I say, well, I don't want to have that conversation, and none of you do. And that's one of the main things for me. What if I'm wrong? However, if I'm doing something for fun, all bets are off. So with that said, I hope I've given you a couple of reasons why you should live patch your interpreter. Obviously, there are some cases where if you apply this judgment, it makes sense. If you don't care if you're wrong, if you're doing it for fun, if you're doing it for debugging or documentation generation, where the deliverable is not the code that you're writing, but some artifact of the code. If you're doing some analysis, for many of you doing data analysis, nobody cares how you did that data analysis. They don't care if you used Python, used R, used MATLAB. They care what the suggestions or the recommendations that you're making based on analysis are. Then in those cases, you can employ whatever sophistication you desire as long as you get your job done. Because if you're wrong about the technical sophistication, as long as you're not wrong about the results, you're okay. At the same time, don't patch a live interpreter. Because there are many cases where this is going to absolutely blow up in your face. You can add some amazing things to CPython very easily, but you probably don't want to be the person who gets called at 3 a.m. when they say your thing broke again. So I couldn't tell you strictly whether you should or shouldn't patch your Python interpreter. This is why I put a slash in the name. Do or don't, but try and think a little bit deeper about the justifications and the judgment that you employ when you decide to use technical sophistication. Because it is a very big consideration in all of our work. This is Don't Live Patch Your CPython Interpreter. I'm James Powell. Thank you very much. Oh. And P.S., there's a PEP 523 that allows you to do a lot of this stuff safely. Yeah. It allows you to add, I'll show you the PEP. It allows you to add frame evaluation API, so you can patch ceval.c in a C module, and it's done safely and correctly. And the reason they added that was, or the reason they're pushing for this, it hasn't been accepted yet, but the reason this is being pushed for is certain projects like the Pigeon JIT for CPython want to be able to JIT Python code. So they want to swap out the ceval loop that a normal CPython interpreter uses for one that JITs the code. It doesn't make a big difference. It doesn't make any difference to somebody who's just writing Python code. They won't see the difference other than the code runs faster. But you need to make some fairly sophisticated low-level changes in order to do the JITting. So there's that. Is anybody going to actually use any of this stuff? No? Who has it? The rename hook. So one question I have for you, since you don't have any questions for me, and I still have 5 minutes of your time, I'm going to ask you some questions. Have any of you ever done something where a day later you said, that I didn't really do that to solve the problem or to do what was best for the person I'm working for. I did that just to play with something and make myself happy. Have any of you ever done that? No, you're lying. All of you should raise your hands. Everybody does that. Have you ever done that and you put a lot of effort into it and then you said, now that I've actually made it work, let's never touch this again or ever actually use it? A couple of you, right? Have any of you ever gotten into a very heated argument with one of your coworkers as to whether something was too crazy or wasn't crazy enough, where they said, you can't do it this way, and you said, no, there's this circumstance or this circumstance? Have you ever gotten into that kind of argument? A couple of people. Were you on the side for doing it more sophisticated or the side for doing it less sophisticated? Who are on the side for doing it more sophisticated? Who are on the side for keep it simple, stupid? A bunch of you. When you're on the side for doing it more sophisticated, what kind of things did you say? It's okay, it's not that hard, it's just code. Is that what you said? What kind of things did you say? How'd you make your case? How did you employ your judgment? What tools did you use as a highly paid individual to say, we're all professionals here, we're all adults here, let's get it done? What did you do? What did you say? Or people on the other side, just shout it out.
My argument is always like this: keep it simple, so people coming next should be able to maintain it.
So does that mean that you avoid using advanced features of Python because people who don't know Python? So you can see it, you kind of wheel it back a little bit.
So I have actually done some open source contribution in the PyData, which is a kernel for the Python, and where I had made a lot with the Python frames and other things. And when I'm seeing into your R-Watch, it seems like another layer on top of a Python frame, or is it like something equivalent to a Python frame?
I'm not very familiar with PyDev, but maybe if we look at that after the talk, we can answer the question.
Every 6 weeks, I try to convince my teammate we need to override operator delete for our class in C++. And that says reaction as well. But I've never been able to convince him that it's actually the right solution.
So that happens. One thing that I've had in many cases is, I was working in a company once, and we had this database. And the database schema that we had was what they called an entity attribute value schema. So it didn't actually use the tables or any of the features of the database. And I looked at it and said, we're just doing this so that we don't have to go to the DBA teams and we can store arbitrary documents. Why don't we use a NoSQL database? And the person who was in charge of the project looked at me and said, what? Nobody actually uses those. And I was like, are you stupid? Like, seriously, have you ever worked with somebody and you're like, can you please use version control? And they said, well, you better get that fancy version control out of here. We tar things up and name them -1 final in where I'm from. You ever been in that situation? I have. I think a couple of you have been in that situation. You're like, we should use Python. And they're like, what do you mean, Excel's not good enough? Bash scripting isn't good enough? What you can see is that the technical sophistication argument occurs at many levels in many different micro and macrocosms. And so what you think and you take to be par for the course, oh, use Docker, why not? Other people look at it and they say, what do you mean use Docker? Why can't we just, why can't we just have single processes on machines and spend 10 times as much on resources and have one server per service? That's an argument that you have to make. So, well, I hope you enjoyed that. Thank you very much.